Modern physics is written almost entirely in the language of geometry. General relativity treats gravitation as the curvature of spacetime. Most approaches to quantum gravity assume that spacetime geometry is either fundamental, or that it emerges from something else that is also geometric. This works. The empirical success is not in question. But empirical success does not settle what is fundamental. A structure can encode the relations among observables perfectly well without being the thing those observables are made of. Temporal rate ontology starts somewhere else. It begins with succession. One event gives way to another, in an order that cannot be reversed. That is the primitive. Notice what is not being assumed. No duration. No metric. No clock. Succession here is purely ordinal. It says that one event comes after another, and nothing about how much time passed between them. Time as a quantity is not put in at the start. What does ordering require? 3 conditions. No event precedes itself. If one event precedes a second, and the second precedes a third, then the first precedes the third. And no closed chains exist, nothing loops back to become its own predecessor. Together these define a growing partial order of events. And a growing partial order is a directed acyclic graph. On this account, that graph is not a picture of something else. It is what there is. A network of events, growing by the addition of new events and new succession relations. Now, one constraint governs that growth. The network must remain acyclic under every admissible extension. Northwest growth step may close a loop of succession. That single requirement restricts which extensions are permitted at every stage, and so the structure of possible futures is shaped by the demand that the whole thing stays coherent. Which brings us to the central quantity. From any given state, ask a simple question: how many admissible continuations of a given depth are there? That number is the continuation multiplicity. Its logarithm is the continuation complexity. In constrained growth models, these quantities are finite, strictly positive, and computable. They are not decorative. They are the objects the framework is built from. But consistency alone is not enough. Consistency tells you which extensions are allowed. It does not tell you which one actually occurs. Something more is needed to select among the admissible. That is the principle of maximal freedom. Admissible extensions are weighted according to the continuation space they preserve. Extensions that keep more futures open are favored over those that close them off. The motivation is a kind of self-consistency. A history that collapses its own continuation capacity progressively restricts what remains admissible to it. Histories that preserve richer continuation structure remain viable under iteration. Now we can say where temporal rate comes from. Take the logarithm of continuation multiplicity and normalize it by the horizon depth. What you get is an intensive quantity, a measure of how fast the space of accessible futures expands in a region. That is the effective temporal rate. It is not an intrinsic property of an event. It is a relational property of local network structure. Regions with many admissible continuations relative to their constraints run fast. Densely constrained regions run slow. And finally, geometry. When these rates vary smoothly from one region to a neighboring one, they can be encoded as a continuous field. That encoding is spacetime geometry. Geometry is not discarded. It remains indispensable as a language for expressing physical relations, and the empirical content of general relativity is preserved. What changes is its status. It becomes a representation of the underlying coordination structure rather than the substrate of it. That is the framework. Succession first. Consistency as the constraint. Continuation multiplicity as the central quantity. A selection principle over admissible futures. Rate and geometry derived rather than assumed. How could it fail? The framework would be undermined if global consistency and maximal freedom proved logically incompatible. If the selection principle produced only trivial continuation structures. If evaluating continuation freedom self-referentially proved incoherent. If spacetime geometry were shown to possess irreducible causal powers. Or if a rival ontology reproduced the same explanatory scope using strictly fewer primitives. At this stage the risk is structural rather than observational. That is a real limitation, and it is stated deliberately rather than hidden.